Hello there. Welcome to Engineering Drawing Made Easy. In today's video, we are going to work on this tangency problem. And like the previous videos, we are going to try and decode this entire problem, see how we can draw it step by step. Then we go on to actually do it on the drawing sheet. So this will just help you understand what is going on and why we are drawing this particular line or doing this particular using this particular principle. Yes, let me put it that way. Yeah. In the previous video, I made mention of something that tangency is mostly all about the location and the distance, right? And in tangency, the location here becomes either the center of a circle or the origin point of a line, and then the distance is the radius of the circle, or the distance or the length of a line. So mostly whenever you see the dimension, try and see it in this kind of principles, the location and the distance as well. Here we have a bit a bit of a bit complicated figure compared to the previous one that we did, right? Because we have one circle here that has a radius of 7 millimeters, right? It has a radius of 7 millimeters, and we have another circle that has a radius of 32 millimeters here, and we have this one having a radius of 26 millimeters. So let's start by trying to draw out the circles, and that would give us straightforward understanding of the relation of the circles. I mean, we've done a couple of videos now, so we should be understanding how these things work. Yes. If it's your first time to we'll still take our time through the entire thing. But if we draw out this circle of radius 7 centimeters, we would have something like this. And if you draw out this circle of radius 32 millimeters rather, we should have something like this. And then if we draw out this circle of radius 26, we should have something like this. Let me different colors to make it a little more visible. So this circle has a radius of 7 millimeters, right? This is as close as I can get. And we have this particular one touching it externally, right? So this with a radius of 26 millimeters touches externally here. This is much better. And then we have another one here with radius 32. Okay, yes, this is a bit better. So if you have a look, we have our first circle here of radius 7 millimeters, and it touches the big circle with radius 32 at exactly one point here. The whole idea of drawing out the circles is to give you clear understanding of the relation between the circles. So it's important to understand the principles of tangency, and that in line helps you to be able to draw whatever you need to draw. Yeah, so would go back and do it step by step from here. Right. We've already seen the various figures that we have, and we know how to go about it. Right. Once again, this circle falls on exactly this circle falls on this line, exactly this point on the line, and this particular one, both of them kind of have some relation with this this point, right? So I would start off with the center line, because that is the easiest to draw, and that kind of solves the issue when it comes to location for most of the figures or features. So you have your and then um let's say we have points A and B. If this lesson is helpful so far, don't forget to subscribe so you don't miss upcoming tutorials. And this circle of radius 7 millimeters, right, is exactly on this point at point A. Now, there's another dimension here, given that the distance between the center and this point on the line is 7 um, millimeters. Okay, this even proves the other tangency principle or relation that says that if you have a line tangent to a circle at exactly one point, the distance between the center and then the point of tangency is the same as the radius. So this circle has a radius of 7 millimeters, and this dimension here is telling us that the distance between here and here is also 7 millimeters. So clearly the center line touches this circle at exactly one point. Come here, and then yeah. At point B, we measure a distance of 7 millimeters to get the center point. That is a bit too high. 7 millimeters to get the center point of that arc, and then we draw our arc here with radius 7 millimeters. Now we go to the next arc, and getting the next arc is going to be a bit tricky, but it's not that difficult. So you just take your time and you get it right. So we have this arc, right? This arc here touching this arc externally, and we know that this arc touches this line at exactly one point. So with these two relationships, we can find the center for the arc with a radius of 26 millimeters. The tangency relationship for two arcs touching externally states that you add up the radii. So we have a radius of 7 millimeters here, and you have a radius of 26 millimeters here. You add that, and that will give you a location where the center would fall, right? So that gives us 33 millimeters. You go a bit further because the arc will go down. Yes. So you stand here, and with a radius of 33 millimeters, you draw an arc. Change the color. So from point here, the center of this circle, radius of 33, you draw an arc. You draw an arc. Now, the center for this circle will fall on somewhere on the 33 arc that we've drawn here. So then the next thing is to use the other tangency relationship to find a specific point, and that would be the relation between the center and then the points, a point on the circle, right? So as you can see here, this is a point on the circle, and the distance between the point on the circle to the center of the circle is the same as the radius, as just as it's shown here. So from this point that we've already found, I just realized that we've not found the points yet. I forgot to mention, or did I mention that earlier? But the distance between this and this is is 45, right? Because then it's stated here in the dimensions that the distance between this point and then this particular arc here is 45. So without marking that out, it will be a lot hard to even know the location. It goes back to what I was saying earlier, that with tangency you'd have to pay attention to the location and the distance, right? I forgot to mention that at the beginning of the video about this distance, right? So the reason why you draw your center line out and mark A, B is to get to measure and get the distance 45. Sorry about that. And that point A here is the same point that we have here for this particular arc, right? So you come there, and then with a radius of 26, okay, with a radius of 26, you draw an arc. So as I was saying, the distance between a point on a circle to the center is the same as radius. That is why from point A we are using 26, because it's just on the same line. Yes. Now with your compass at this point here, you open up to a radius of 26, and or you can just simply open up to point A. It should be the same thing as 26 if the how do I put it, if you've done everything right, it should be the same distance, yes. And then you draw an arc, through to touch it here. That gives you the first how do you say it, the first arc from the line, right? And then you go on to the next line, which would be from this direction. So it's a lot similar to the one we just did. The only difference is that it's touching at here internally. So the first one was kind of an external relationship, and this is an internal relationship. So that's what makes the difference. So you come here with your compass, and you come here with your compass, and with a distance of 32 minus 7 giving us 25, you draw an arc. And now I'm sure you get why we subtracted the 7, because then they are touching externally, and based on the tangency rule you'd have to subtract it. Moving on to this point from the line, right? Since this arc touches the line too at exactly 1 point, it's going to be similar to the previous one that we did. The distance between the points on a circle to the center is the same as the radius. It's point A here, you open up 32 and you draw an arc. Now that gives the center for the last circle. When you come here, you either open up to A or you open up to radius of 32. It should be the same thing, I mean, if you do the work right. So, or if you had if you took the right approach. So you open up to radius of 32 and you draw your arc. That should be able to give you the figure. This is not that complicated, but it requires you to understand exactly what you are doing, and then the principles of tangency that you are using. It's part of the reason why I decided to have this session where I explain all the various parts, the various figures, before I go on to use the drawing board, so that you get to understand why everything is being done the way it's being done. Yeah, so if you have any questions or any suggestions or anything that you don't quite get, you leave it in the comment section, and I would reply to that for you. And also, if you have any other tangency problem that you like that work on it, you can also share it in the comment section or through the chat session, and that would also be sorted out for you. It could even be featured in the next video. Yeah, so that'll be all for today's video. I hope you understood, or you got what we are trying to do, and it was really helpful for you. This is one of the easiest that you can still have under tangency problem. So if you don't quite get it, you'd have to relax, rewatch the video, and try and see if there are you can make improvements in it. Also share it with your colleagues, and if the video is helpful, you like and you subscribe to the channel. It helps the channel grow and increase the reach, so I'd really much appreciate that.